Welcome to Ask and Learn.
We're given a deterministic finite-state automaton, and we are asked to find the language recognized by this automaton. The automaton can be found in problem 19 of this section. Now, the figure we're given contains three states, S0, S1, and S2. And so I'm going to construct a table with two columns. In one column I have the different states, S0, S1, and S2. The other column, the inputs, which are only allowed to be 0 or 1. And now, if there's an arrow from state Si to a state Sj with a label of x, what we'll do is write down Sj in the row Si and in the column x of the table. So for example, we see that there is a arrow from S0 to itself with a label of 0 on it. So what I'll do is I will write S0 in the row S0 and under the column 0. And likewise, we fill out the rest of the table. We also see that S0 is marked as the start state. We see that S1 is circled twice, which means that S1 is a final state. In fact, it's the only final state. And so we have that a string will be recognized by the deterministic finite state automaton if we end at state S1. So let's break this into cases. Suppose that the string starts with a 1. Then we see from our table that we move from state S0 to state S1. Now we see that we remain at state S1 if the remaining string contains only 1s. Otherwise, if there is some 0 in the string, then the table tells us that we move from S1 to S2, and then once we're in state S2, we'll always remain at that state. So it follows that all strings consisting of only 1s, and at least one 1, are in the recognized language. So we have set containing 1 concatenated with the clean closure of the set containing 1. It's a subset of the recognized language. Now for the next case, suppose the string starts with a 0. We see that the rules in our table tell us that we remain at state S0. And in fact, we're going to remain at S0 until we obtain a first 1. So we're going to suppose the remaining string has a 1 in it. Then at that point, we're going to move from S0, according to our table, we'll move to state S1. And now, once we're at state S1, suppose that the remaining string contains only 1s. Then we're going to remain at state S1, which is a final state. Otherwise, if there is a 0 in the remainder of the string, then we're going to move from state S1 to S2, and then we'll be stuck at state S2. So it follows that all strings consisting of only 1s and at least 1 1 are going to be in the recognized language. So this is, in summary, all strings starting with a 0 and then followed by any sequence of zeros, followed by a 1, followed by any sequence of 1s, are in the recognized language. So as set notation, I'll write this as concatenation of set containing 0, the clean closure of the set containing 0, set containing 1, and the clean closure of the set containing 1. This is a subset of the recognized language. Now, since these are all the possible cases, it follows that the language generated by the machine is the union of all these sets. So L of M is going to be 1, 1 star, union with 0, 0 star, 1, 1 star. And we see that this can actually be abbreviated as, since the first element can be either 1 or 0, this can be abbreviated as 0 star, and then after that, a 1, and then a 1 star. So in other words, this is the set of all strings which have any sequence of zeros followed by any sequence of 1s with at least 1 1. So this is our answer.